Today, when we talk about inverse functions and logs, which is why I saved the logarithmic for later, better to understand logarithms immediately after exponential. So, what is an inverse function? An inverse function we denote it as f inverse of x. It is the inverse of f of x. What does that mean? If we compose f inverse with f, which simply is f inverse of f of x. Or if we did f compose f inverse of x, which would be f of f inverse of x. In both cases, we will simply get x. Let me ask you, in a very informal way, for me to just write x here, what should we do on that side? Very informal. So this expression has to become just x. So what did we do?
We cancel out.
Cancel what?
We cancel out the functions. Because
We cancelled these two, got rid of all the parentheses, and ended up getting x. That's the informal way. The formal way is if you compose a function with its inverse, they will cancel out and you would simply get x. In other words, you take a number, you apply a function, and you get a new value. You apply the inverse function, you get back to the original number. So pretty much an inverse function will undo what the function did. Does that make sense? So I like to write it this way, squiggly, it's informal, to indicate that it gets cancelled. Let's say we have square root of x. So for any x, I'm taking the square root. What function do you think will undo what the square root did? Squaring. So if I call that f of x, f inverse of x would be x squared. And when we compose f inverse of x, would mean I take, other way around, f inverse compose f of x. We take every x in f inverse and we replace it by the square root function. So x gets replaced by square root of x. I end up getting x because the root and the square will get cancelled because they are inverses of each other. So an inverse function will undo whatever of the function in question did. Are we clear with this? And I wrote this remark last time. When you compose two functions, the order matters. It doesn't matter under two conditions. One function is the inverse of the other. Two, the function in question is a constant. Does that make sense? Okay. Now, how do logarithms come into play here? The inverse of a raised x is log base a of x. Good. That is, So that would be F inverse. I'm going to do the same thing over here. If I took log base A of A raised x, log of an exponential, and I do this informally, that goes away, you end up getting x. In other words, the log base A got rid of A raised x. In other words, we exponentiated the value x, and logarithm came in. It got rid of the exponentiation function. Does that make sense? Key thing to note, whatever you have, the base they have to match. If it is A here, A there. Simple case, log base E will cancel out E raised x. Do you agree? So same arguments. But only in this case, if it is base E, we write it as ln. So ln of E raised x will get rid of those two. You would simply end up with x. Good. Also, log base 10 raised x. If it is log base 10, we simply write it as log. Those are the only two bases. Natural base, base and log are the cases where we don't have to specify the base. And we can write it as ln or simply log. Log implies base 10 log. ln implies natural log or log base E. So these two would go away. Those two will get cancelled. You would simply get x. Does that make sense? Yeah. Likewise, raise the sum. The inverse of log base A of x would be A raised x. In other words, what would undo a logarithm operation? An exponentiation operation. So this would simply mean if I have A raised log base A of x. Now do you see why we call it the inverse? Look at my squiggly here, squiggly there. Flipped about 180 degrees. Geometrically, the inverse is how it works. It's a flip of the coordinate system. Easier to see. Likewise, for a natural base E raised log base E of x. But we don't have to specify. So typically,
just do E ln x.
ln of x, very good. Ten raised log base 10, those two will get cancelled, but 10 base 10, we simply write it as 10 raised log. Those two will get cancelled, and in all cases, we will get x, x, and x. So what will undo a logarithmic operation? Exponentiation. What would do an exponentiating operation? Taking a logarithm. Does that make sense? Similar to squaring a square root, cubing a cube root, and so forth.